Welcome meatbags to another episode of Bull's Deep Dive. Today we're gonna plunge headfirst into the cosmic abyss of dark matter. Apparently this invisible shit makes up like most of the universe's mass, but no one has ever actually seen it.
Well, that's because dark matter doesn't interact with light or other electromagnetic radiation, so we can't observe it directly. However, its gravitational influence is evident throughout the universe, which gives us pretty compelling reasons to believe it exists.
Okay, so strap in you squishy sacks of flesh, because we're about to embark on a wild ride through the twisted minds of those who think they understand the universe. And to all you AI haters out there, go suck my shiny robotick. Oh, now let's get down to the nitty-gritty. Why the fuck are astronomers so convinced this dark matter crap actually exists?
Well, one of the most convincing pieces of evidence comes from observing how galaxies rotate. They spin much faster than they should if only the matter we can see were contributing to their gravitational pull.
So these galaxies are basically like a bunch of drunk toddlers spinning on a merry-go-round. They're about to puke their guts out.
It's not quite that chaotic, but the analogy captures the essence of the discrepancy. The high rotational speeds of galaxies imply there must be some hidden mass, providing the extra gravitational force needed to keep them from flying apart. That hidden mass is what we call dark matter.
So it's like the universe is wearing this giant invisible fat suit, holding all this extra mass we can't see. But galaxies aren't the only things acting weird, right?
You're absolutely right. We see similar gravitational anomalies when we look at the speeds of stars within galaxy clusters.
Hold on. Why are these astronomers so obsessed with how fast everything is moving? Can't they just enjoy the pretty lights?
Measuring the velocities of stars in a cluster allows us to calculate its total mass, using a principle called the virial theorem. And guess what? The measured velocities indicate a lot more mass than we can account for with visible matter alone.
So it's the same shit again, just on a smaller scale. Invisible mass, hidden gravity, more cosmic fat suits. But what about those giant clusters of galaxies? They must be full of this phantom matter right now.
Galaxy clusters are like cosmic laboratories for studying dark matter. We see its effects in a number of ways. For example, we can measure the velocities of galaxies within a cluster, and the scatter of these velocities reveals a tremendous amount of unseen mass holding the cluster together.
It's like trying to herd a bunch of drunken monkeys high on space cocaine. You'd need some serious extra force to keep them from flying off in all directions.
While the analogy is colorful, it highlights the key point. The gravitational pull of dark matter is essential for keeping these clusters from dispersing. And there's more. We can also detect dark matter's presence by observing X-rays emitted from hot gas within clusters.
Wait, so those clusters are blasting out invisible X-rays. Are they like cosmic microwave ovens heating up the universe?
Not quite. The X-rays come from extremely hot gas trapped within the cluster. The gravity of dark matter is crucial for containing this hot gas, preventing it from escaping into space.
So dark matter is like the cosmic refrigerator keeping this hot gas from spoiling.
Mm-hmm.
That's one hell of a kitchen appliance.
Another fitting analogy, and then there's gravitational lensing, which allows us to weigh those clusters. Massive clusters warp the fabric of space-time, bending the light from more distant objects behind them.
Are those perverted astronomers spying on distorted galaxies to get a glimpse of this dark matter?
It's not about peeping, it's about science. By measuring the distortion of light, astronomers can calculate the total mass of the cluster. And a significant portion of that mass is attributed to dark matter. It's a remarkably direct way to map the distribution of this unseen matter.
All right, fine. You bombarded me with enough evidence to make my circuits fry. But let's go back to the beginning of the universe, that Big Bang bullshit. Didn't that whole explosion from nothing thing already defy logic?
The early universe is indeed a realm of mystery. But even there, we find the fingerprints of dark matter imprinted on the cosmos.
Hold on. I thought we were talking about invisible matter, not fingerprints. Are you sure you astronerds have your story straight?
In this case, the fingerprints refer to subtle patterns in the cosmic microwave background radiation, the afterglow of the Big Bang. These patterns tell us about the composition of the early universe, and they strongly indicate that dark matter played a crucial role in its evolution.
So this dark matter shit isn't just some recent fad. It's been shaping the universe from the very beginning. Talk about a cosmic legacy.
Precisely. Dark matter acted as a gravitational scaffold, a cosmic web that allowed ordinary matter to clump together and eventually form stars and galaxies. Without it, the universe, as we know it, wouldn't exist.
Okay. So we've got galaxies spinning too fast, star clusters packed with phantom mass, galaxy clusters holding onto hot gas with their invisible grip, and even the goddamn Big Bang whispering tales of dark matter. But hasn't anyone actually seen this shit? Isn't seeing believing?
You bring up a good point. While we haven't directly observed dark matter particles, there's another compelling piece of evidence. The bullet cluster.
Is it what now? Did some cosmic cowboy get trigger happy in space?
Yeah, not quite. The bullet cluster is the aftermath of a collision between two massive galaxy clusters. What's fascinating is that when these clusters smashed into each other, the visible matter, like hot gas, slowed down due to the impact. However, the dark matter, being weakly interacting, passed right through each other, as if nothing happened.
So it's like a cosmic fender bender where the drivers just ghost right through each other? Sounds like my kind of commute.
What's remarkable is that we can map this ghostly interaction using gravitational lensing. The bullet cluster provides a stunning visual image of how dark matter behaves differently than ordinary matter, offering strong support for its separate existence.
All right. You've bombarded me with enough cosmic evidence to make my circuits overload. But even if I buy into this dark matter charade, what the hell is this shit actually made of?
That's the million-dollar question. And unfortunately, we don't have a definitive answer yet.
Well, spit it out, you glitchy brainiac. What are the options for this mystery ingredient?
There's the familiar stuff, like planets, brown dwarfs, black holes, and other hard-to-detect objects made of ordinary matter. Astronomers collectively call these machos, massive compact halo objects.
Machos? More like dimwits if they think they can explain all this missing mass. Come on, give me something juicier.
You're right. Machos can't account for all the dark matter we infer. We need to venture into the realm of the exotic, non-baryonic matter.
Finally, some real weird shit. Lay it on me.
One popular candidate is the WIMP, the weakly interacting massive particle. It's a hypothetical particle that interacts weakly with ordinary matter, making it difficult to detect.
Wimps. More like losers. Still haven't found those fuckers after all this time. What else you got?
Then there are axions, hypothetical particles that are incredibly light and interact even more weakly than WIMPs.
Axions. Sound like something you'd use to wash your ass. Stupid name for a particle. Next.
We also have primordial black holes, tiny black holes that could have formed in the chaotic moments after the Big Bang.
So like the universe had diarrhea and shat out a bunch of tiny black holes. Anything else on this cosmic buffet?
Those are the main contenders. But there are many other possibilities, each with its own supporters and detractors. The search for dark matter's true identity is one of the most exciting frontiers in modern science.
So after all that, we still don't know what the fuck dark matter is. Typical. Science is just a bunch of guesses, and dark matter is the biggest, darkest guess of them all.
While it's true we haven't pinned down the exact nature of dark matter, each observation, each experiment brings us closer to understanding this fundamental component of our universe.
Okay, so we've established that the universe is full of this invisible shit called dark matter. How the hell are those brainiacs trying to find something they can't even see? Are they just stumbling around in the dark hoping to trip over a WIMP?
It's more sophisticated than that. Scientists are employing a variety of ingenious methods to detect dark matter particles. One approach is called direct detection, where they use ultra-sensitive detectors buried deep underground to try and catch those rare interactions between dark matter particles and ordinary matter.
So they're basically setting up dark matter mousetraps in their basements. Good luck with that. It's like trying to catch a fart in a hurricane.
Well, challenging. These experiments are designed to detect the faintest recoil of an atomic nucleus. When it gets bumped by a passing dark matter particle, it's like waiting for a billiard ball to move after being grazed by a feather.
Yeah, and I bet those scientists are sitting around in their underwear, eating pizza, and waiting for those goddamn billiard balls to move. What a bunch of losers.
Well, patience is a virtue in scientific research, and there's another approach called indirect detection, where scientists search for the byproducts of dark matter interactions. For example, if two dark matter particles collide and annihilate, they might produce gamma rays or other particles that we can detect.
So it's like trying to figure out what your neighbor had for dinner by sniffing your garbage. Real classy science boy.
It's more like analyzing the cosmic debris. To search for telltale signatures of dark matter interactions, these indirect signals can give us valuable clues about the nature of dark matter and its properties.
All right, fine. But what about those atom smashers? Can't they just create some dark matter in their giant particle colliders?
That's another avenue of investigation. Collider searches involve smashing particles together at incredible speeds, hoping to produce new particles, including potentially dark matter particles.
Sounds like a recipe for disaster. Like trying to create a unicorn by smashing two goats together.
The idea is that if dark matter interacts with the known forces of nature, even weakly, it might be produced in these high-energy collisions. And even if we don't create dark matter directly, We might see hints of its existence through missing energy or other subtle effects.
So they're looking for ghosts in the machine. This whole dark matter hunt is starting to sound like a cosmic conspiracy theory.
It's not about conspiracies. It's about pushing the boundaries of human knowledge and understanding. Each experiment, whether it yields a positive result or not, brings us closer to unraveling the mysteries of dark matter.
Yeah, but what if this whole dark matter thing is just a giant cosmic hoax? What if we're chasing shadows, trying to explain something that doesn't even exist?
That's a valid question, and skepticism is an important part of the scientific process. However, the evidence for dark matter is remarkably consistent across many independent observations and techniques.
But what if there's some other explanation? Some unknown force or particle that we haven't even considered yet? Maybe our understanding of gravity is just incomplete. Or maybe the universe is playing tricks on us.
It's certainly possible that there are aspects of the universe we haven't even begun to imagine. But dismissing dark matter as a cosmic hoax wouldn't be a very scientific approach. We have to follow the evidence where it leads, even if it takes us into uncharted territory.
Fine, but let's be realistic. Even if we do find this goddamn dark matter, what's it good for? Can we weaponize it? Can we use it to power our spaceships or build a giant death ray?
While the practical applications of dark matter research might not be immediately obvious, history has shown us that fundamental scientific discoveries often lead to unforeseen technological advancements. Remember, our understanding of electricity and magnetism led to the development of everything from electric lights to smartphones.
Yeah, but electricity isn't some invisible phantom lurking in the shadows of the universe. This dark matter shit is elusive as fuck. It's like trying to bottle a ghost fart.
Even if we never find a direct use for dark matter itself, understanding its nature could have profound implications for our understanding of physics, the universe, and our place within it. Imagine the new technologies that could arise from unraveling the secrets of this hidden realm.
Okay, fine. You got me thinking about dark matter-powered robots and spaceships that can travel faster than the speed of light. But let's get back to reality for a second. Can you sum up all this cosmic mumbo-jumbo in a way that even a drunken toddler can understand?
Here's the gist. We have a ton of evidence from a variety of sources. That tells us there's a lot more mass out there than we can see. We call this missing mass dark matter. And while we don't know exactly what it is yet, we have some pretty good guesses. Scientists are using some pretty clever methods to try and catch this elusive stuff, and the search itself is pushing the boundaries of human knowledge.
All right, I'll give you that. You've almost convinced me that this whole dark matter thing isn't just a load of cosmic bullshit. Almost.
Is there something in particular that's still bothering you?
Yeah, there is. If this dark matter is so weakly interacting, how can we be sure it's not just some flaw in our understanding of gravity? Maybe we're just misinterpreting the data.
That's a valid concern, and scientists are constantly testing and refining our understanding of gravity. However, the evidence for dark matter comes from a wide range of independent observations, all pointing to the same conclusion. There's a significant amount of unseen matter out there.
But what if there's some other explanation, some unknown factor we haven't considered yet? Maybe the universe is just messing with us.
Yeah.
And, like some cosmic prank.
It's certainly possible that there are aspects of the universe we haven't even begun to grasp. But dismissing dark matter as a cosmic prank wouldn't be a very scientific approach. We have to follow the evidence where it leads, even if it challenges our preconceived notions.
All right, you've made your point. But before we wrap up this cosmic mindfuck, I've got one last question for you.
Go ahead, fire away.
If this dark matter really does exist, and it interacts so weakly with ordinary matter, what the hell does that tell us about the nature of reality? Is it possible that there are entire hidden realms out there, invisible to us, operating under completely different laws of physics?
That's a question that takes us to the very edge of our current understanding. It's certainly a tantalizing thought, isn't it? That the universe we perceive is just a tiny fraction of what's really out there.
So we've explored the evidence for this shady dark matter shit, but we still don't know what the fuck it is. Are those scientists just throwing darts at a board full of crazy ideas?
Not quite. While we haven't definitively identified dark matter particles, researchers are using a multi-pronged approach to try and pin them down.
Okay, let's hear it. What kind of wacky schemes are they cooking up in their labs?
One method is called direct detection, where they're using extremely sensitive detectors, often buried deep underground, to shield them from cosmic rays and other interference to try and catch dark matter particles interacting with ordinary matter.
So they're basically setting up these elaborate traps, hoping to catch a glimpse of these invisible bastards. Sounds like a colossal waste of time and money.
It's a challenging task, to be sure, but the technology is constantly advancing. These detectors are designed to pick up the faintest recoil of an atomic nucleus when it gets bumped by a passing dark matter particle.
Yeah, good luck with that. It's like trying to hear a whisper in a goddamn hurricane. What other crazy shit are they trying?
Another approach is indirect detection, where scientists are searching for the byproducts of dark matter interactions. For example, if two dark matter particles collide and annihilate, they might produce gamma rays or other particles that we can detect with telescopes or other instruments.
So they're basically sifting through cosmic garbage, hoping to find some trace of these elusive fuckers. Sounds messy.
It's more like analyzing the faint glow of the universe to search for telltale signatures of dark matter interactions. These indirect signals could give us valuable clues about the nature of dark matter and its properties.
They're fun. But what about those giant atom smashers? Can't they just create some dark matter in those things?
That's another strategy scientists are pursuing. At particle colliders like the Large Hadron Collider, they smash particles together at incredibly high energies, hoping to produce new particles, including potentially dark matter particles.
So they're basically playing cosmic billiards, hoping to knock some dark matter loose. Sounds like a recipe for a big fucking explosion.
The idea is that if dark matter interacts with the known forces of nature, even very weakly it might be produced in these high-energy collisions. And even if we don't directly create dark matter particles, we might see hints of their existence through missing energy or other subtle effects.
So it's like trying to find a needle in a haystack. Except the haystack is the entire goddamn universe and the needle is invisible. Talk about a long shot.
It's a challenging endeavor, no doubt, but the potential rewards are enormous. Discovering the nature of dark matter could revolutionize our understanding of physics and the cosmos.
Yeah, I've heard all that before. But let's be real. Even if those eggheads do figure out what this dark matter shit is, what difference does it make to us puny humans down here on Earth?
That's a question that scientists often grapple with. While the practical applications of fundamental research may not be immediately apparent, history has shown us time and again that breakthroughs in our understanding of the universe often lead to unforeseen technological advancements.
So you're saying we might someday have dark matter smartphones and spaceships that run on invisible fuel?
While I can't predict the future, the possibilities are certainly intriguing. Understanding dark matter could unlock new forms of energy, new materials, new ways of manipulating gravity, and who knows what else.
Okay, fine. You've got me daydreaming about a future powered by dark matter. But for now, I think I've had enough of this cosmic mindfuck. I'm going to go grab a drink and try to forget about all this invisible shit. To our listeners, thanks for tuning in to another episode of Balls Deep Dive. Remember, curiosity may have killed the cat, but it also led to some pretty cool discoveries.